Great people, welcome to NumTech channel. This is lesson 10 on NumPy universal functions, and we are going to learn NumPy trigonometric functions. But then before we begin, please subscribe to the channel if you have not subscribed, and to the returning subscribers, thank you very much for your continuous support. So guys, basically NumPy provides the universal function for sine, cosine, and tangents that take values in radians and produce the corresponding sine, cosine, and tangent values. So guys, basically let me show you an example how to find the sine value, perhaps of a pi over 2. Let me show you guys an example here. Let me just type here. So first of all, we are going to import NumPy. With the, let me use the small import NumPy is np alias then here let me create here an object. Actually let me create here a variable, then let me assign it to np dot sine then create this parenthesis, then here let me say np dot pi over 2 pi over 2, and then here to the print function, let me say what, let me say print. We're going to print what, x. We're going to pass x, then let me run the codes. And so guys, basically this is how we can find the sine of the values of this pi over 2. But then let's try to find the values of the values in the array. So the same procedure follows. You must import NumPy as np alias, but then here we are going to use array. So let me just use a, give it a for array, then let me say np dot array, and then here create the parentheses or the rounded brackets, then let me create here a list. For example, let me begin with np dot pi. Let me begin with pi over 2, perhaps pi over 2, then comma, let me try also with the np dot pi over 3, and then also let me say np dot pi over 4, comma, also np dot pi over 5 dot pi over 5. Then here to create to print out, actually let me create now this new array here. Let me say x, so that it may print out the values there. So let me assign it to np to find actually the sine dot sine, and then we are going to pass a, and then to the print function, let's say print x. We are going to print x, then let me run the codes. And so guys, basically this is how we can find the sine values for all of the values in this array. So guys, let's now discuss how to convert degrees into radians. So by default, all of the trigonometric function take radians as parameter, but we can convert radians into degrees and vice versa as well in NumPy. So remember radians values are in pi over 180 degrees value. Let me guys show you an example how to convert all of the values in this array here, in this array. So what I'm gonna do guys here, or let me just create here new, let me use just a new cell. Let me say import NumPy is as np alias, and then let me create an array with the variable a, then let me assign it to np dot array and dot array, then let me give it these values here. Perhaps let me see 98 degrees, 90, 180, 180 to 70, to 70 at 360 degrees. And then here let me say what, let me say x, then assign it to np dot degree, actually degree to radian. How to convert from degree to radian. And then we are going to pass what, we are going to pass a, and then to the print function, let me say print x, so that it may convert for us these degrees to radians. And then guys, basically this is how we can convert the degrees to to radians. Now guys, let's now discuss how to convert from radians to degrees. So what we do here, let me just use this one here. Where is it? Let me just use this one, or let me just use a new cell, guys. I don't want to confuse you. Let me say import NumPy is np alias, and then let me create also again another variable, another object. Let me use a this time. Let me just use a as usual. Then let me assign it to, remember you can use any variable name or any letter of the alphabetical, you can just use anything provided it's not a inbuilt keyword in Python. Then let me say np dot array, and then let me give it np dot pi over 2, then again here let me say np dot pi, or let me also use this one. Perhaps let me try it with the multiplication. Let me say, for example, 1.5 times np on np dot pi, and then here let me give it perhaps 2 times np dot pi. Then here to convert, we are going to use this function here. First of all, let me create this variable, then let me assign it to np dot, now we are converting from radian to degrees, actually to degrees. So rad to degrees, to degree. Then we are going to pass a, then to the print function, let's say print, we are going to print what, we are going to print x now, so that it can give us the values there. And then guys, basically this is how we can convert from radians to degrees. So guys, let's now discuss how to find angles. So guys, finding angles from values of sine, cosine and tangents, we just use the inverse, like arc sine, arc cosine, arc tangent. So guys, basically NumPy provides the universal function, that is arc sine function, arc cosine function, and the arc tangent function that produces radian values for corresponding sine, cosine and tangent values. Guys, let me show you an example here. First of all, let me import NumPy. NumPy is np alias, then here let me assign it to np dot arc sine, then let me convert this 1.0 to what, to find the angle of this 1.0, and then here let me say print x, then let me run these codes, and then again basically this is how we can find the the angle of this arc sine. And so guys, let's now discuss how to find the angles of each values in an array. So for example, if you are using an array list, let me just copy these codes here. Let me copy, and then let's try with the array. Now here we are going to use, instead of let me just create here an array with variable a, then let me assign it to np dot array, then let me pass what these values here. Remember, a list is defined using these they are called square brackets. Then let me begin with 1, -1, again -1, and then 0, perhaps 0.1, and so forth. So let's try to convert. We are going to use, let me use a variable here, and then let me use np dot arc. Basically it should be arc sign. You can try with the cosine and tangents, but let me just use this sign for the sake of example, for showing you, but you can try as well with the tangents and the cosine. Then let me pass a, and then let's print what we are going to print, x. Then let me run, and then again, basically this is how we can find the angle for all of these sign values in this array. So guys, let's now discuss how to find hypotenuse using the Pythagoras theorem in NumPy. So guys, basically NumPy provides the hypot function that takes the base and the perpendicular values and produces hypotenuse based on the Pythagoras theorem. So let me show you guys an example how to find the hypotenuse perhaps for 4 base and 3 perpendicular. So what I do here, first of all, let me import the module that is NumPy is np alias, and then base, let me give it 3, let me give it a 3. Then perpendicular, let me give it something like 4, let me give it 4. And then to find the to find the hypotenuse, we are going to use this function here. Let me first of all assign to np dot hypot. It should be hypot. Is it so? I think hypot. And then we are going to pass base and perpendicular, and then let's print what? Let me say print the x, and then let me run the codes, and then guys, basically you can see that actually the hypotenuse here is 5. And guys, basically this is all I wanted to show you in these NumPy trigonometric functions, and I think you've gained something. Please consider subscribing, like, and share the video to your friends. Until next time, this is Nehemiah. Goodbye.